Okay, hi everybody. This screencast right here is going to be on homework 3.2, and this is going to be number 5. I did have somebody ask for number 5 to be done. I wasn't sure if it was this number 5 or the one from homework 3.1, but this is homework 3.2, number 5. I'm actually not even going to do the whole thing. I'm just going to set it up for you, and you should be able to solve it. But what I think is probably confusing to people is how you have a rocket moving at different rates right here. Okay, so what we have is we'll do a green rocket guy. All right at ground level. All right, and it's blasting off. Okay, so it's like a little model rocket blasting off at ground level, moving up with an acceleration. All right, the acceleration is 12 meters per second squared. Oh, by the way, what's the initial velocity right here? Initial velocity. In fact, I'm just going to call it the velocity at that point. Equals the initial. Well, that velocity is 0 meters per second, right? Because it starts from rest. All right. The reason I'm not calling that initial velocity quite just yet is because we're going to have 3 different stages. That's what we have to do with this problem. We need to break it into 3 different parts. All right, so the first part is the rocket going from rest, going up to some height. All right, that's terrible. Let's do that again. So some height right here. Sorry. Can't draw rockets today. And so it's shooting out like that. And that height is, what is that height? We know that, I believe, 26 meters, right? So our delta y equals 26 meters from there to there, okay? But it doesn't stop there. In fact, this whole chapter is on free fall. This rocket really is not in free fall at all because of the engine. It's accelerating upwards. It's got an acceleration in the positive. All right, but it's at that point at height 26 meters that the engine cuts out, and now it's no longer accelerating. All right, still moving upwards, but we've reached kind of, you might call it part 2. All right, or part B, and that is where it goes from this moving position right here to, well, a final height. Now, think of this as going straight up and down, not going over and coming down, but it's, I can't draw it straight up and down because all the words get in the way. But it basically reaches its highest point right here. All right, and it goes straight up and then comes straight back down. So what's the velocity at its highest point? An object in free fall? Well, the velocity here is also 0 meters per second, right? Yes, I know it looks like it's moving sideways, but it's actually not. It just gets up to that point and then stops in midair and falls straight back down. And so hopefully this will help. So the third part is going to be the falling down motion. All right, so we've got this phase, or this stage, and this stage right here. So let's just put them all together. We have an initial velocity from this first stage right here. We have an acceleration. We have a displacement right here. We should be able to find a velocity at this point right here. Now, I'm not going to call it the final velocity. I'll call it, well, in fact, I'll let you call it what you want, because, why am I not calling it the final velocity? Well, because if it's the final velocity of this first segment right here, it's also the initial velocity of this second segment. So whatever you want to call it, this velocity, it's the final for this first part. So I'm just going to call it V. Okay, that we don't know, but whatever that velocity is, it's the initial velocity for the second part right here. All right, this final velocity, which I didn't also do a subscript, happens to be 0, right? Because it's moving and then it comes up to 0 before falling back down. So we do know that velocity. But we do not know the displacement. All right. In fact, I will call this displacement right over here. I'll call it displacement of the y. I'll call that 1. I'll call this 2. And then I'll call this whole displacement right here, delta y, I will call that 3. All right, so I'll give you that. If we want to find this whole height right here, we're going to have to add displacement 1 and displacement 2, right? To get that whole displacement 3 height. But this velocity right here is the ending velocity for the first part. It's also the beginning velocity for the second part right here. So, okay, the engine is cut out here. So we don't know the displacement. We should be able to solve for it. What do we know? We do know the acceleration, because now, and only now that the engine is stopped, is it now under free fall. It's not falling. It's still moving upwards, at least for a short period of time. But remember, we said that the free fall, or that if it's under free fall, it simply means it's under the command of gravity, negative 9.81 meters per second squared. So we can apply that acceleration to that second phase right there. So we have an initial velocity, whatever that is. We know the final velocity, we know the acceleration. We should be able to find that, that displacement right there. Okay? And then finally, in this phase 3, we have this going on. We have, first of all, we know the initial velocity for phase 3. What is it? Well, it starts at rest at the top, and then it starts falling down, and the rocket finally hits the ground. We don't know the velocity here. We should be able to solve for that. We don't know this displacement, but if we find this displacement, delta y2, and this displacement, which we know, we should be able to add them together to get this. Okay, and we also do know the acceleration. The acceleration, it is still under free fall, so it's still negative 9.81 meters per second squared. All right, for that part 3 right there. I'm not going to go solve this, but I did want to set that up for you so you would be able to solve each of those parts. Break it down into 3 parts. It's accelerating positively, now it's in free fall, and now it's in free fall again. But we know certain velocities at these different times, and we know the accelerations at all these different times. That should help us find the unknowns that we're solving for. So I hope that helps. Come see me, please, if you have any questions on number 5 on homework 3-2. Thanks for watching. I'll see you later.